Okay, so a 3 by 3 determinant is definitely more tricky to calculate. There's a few different methods that I've learned to calculate the 3 by 3 determinant. So the first is the more traditional method, and it's really one of the most powerful methods because we can use this to find the determinant by hand for any size matrix. So let's start with that. First, just to give you some brief terminology here. If we have a matrix, let's say we call it A, we can label each of the components like this, each of the elements in the matrix. So I'm using subscripts. And the advantage of doing it this way is so we don't run out of letters. Like if we used A, B, C, D, E, F, G, H, I, if we were doing very large matrices, we'd run out of letters. There's only so many letters in the alphabet. So because I'm calling this matrix A, I'm going to call each of the elements lowercase a. And then the subscripts represent the row and the column number. So this A21 is in the second row, first column. So the subscript would be 2, 1. Sometimes people put commas in between these. This way there's no confusion that it's not the 21st row or something weird like that. All right, so ultimately I want to find the determinant of this matrix. So I'm going to replace the matrix symbol and make it a determinant symbol. All right, so I want to find the determinant of this matrix. The way we do this is there's a formula. You're going to pick one of the rows or one of the columns. Most people just pick the first row, but there's really no reason why you have to do that. If you find one of the rows or one of the columns have a bunch of zeros in it, that's the one you should pick. It'll make your life much easier. All right, so I'm just going to pick the first row. And so I'm picking this row right here. What you're going to do is you're going to take each element and multiply it by its minor. A minor is the determinant of everything that's not in that row and not in that column. So I'm going to take A11 and multiply it by the determinant of A22, A23, A32, and A33. Okay. The next step is to do the same thing with the next element, but change the sign. And you're going to keep alternating the signs. So if the first one's a plus, the next one's a minus. So I'm going to cross out the column, cross out the row. We have A12. And let's see. So what's left behind is A21, A23, A31, A33. Okay, ran out a little bit of space here. The last one. Okay, so I'm doing the third element in that first row, cross out everything in that third column, cross out anything in the first row, and we're going to use a plus because we did a minus last time. We're going to put the element in front and then multiply it by its minor, the determinant of what's left behind. So A21, A22, A31, A32. All right. If you don't use the first row or first column, to determine whether you're starting off with a plus or a minus is determined by the sum of the row and column number. So for example, we started off with A11. If you add up the row and the column, you get 1 plus 1, which is 2. If it's an even number, you start with positive. If it's an odd number, you start with a negative, so you start with a minus. So in other words, if we started on the second row, so this would be the same thing really quick, and I wouldn't recommend doing it this way. What we could have done is we could have started with A21 instead. And if we started with A21, we would start with a minus because 2 plus 1 is an odd number. And then we would do the determinant of what's left behind, which would be A12, A13, A32, A33. And then you would add to it the next element, which would be A22, but again, do a plus because we're alternating signs, and you do everything else. So it's going to be A11, A13, A31, A33. And then the last one would be a subtraction. So it would be A23 is the last element in that row, multiplied by the determinant of everything else. Again, cross out that row, cross out that column. So it's going to be A11, A12, A31, A32. All right. Again, most people would just take the first row. That's what people usually do. All right. So let's do an example of this. Let's try to find the determinant of, call this matrix A again because I like A. So the determinant of A is going to be the determinant of this matrix that I'm putting inside the brackets here. It's going to be 5, 1, 1, -5, 2, 0. And let's have my last row be -7, 2, 3. So using this technique, so this might be an example where going down the second row will be easier, but let's just do the first row. So I'm going to just pick the first row. When you pick the first row, you just take that first element, and then you multiply by the minor, the determinant of whatever else is left behind when you cross out that row and cross out that column of that element. All right, so it's going to be 5 times the determinant of 2, 0, 2, 3. And I just crossed out this row, crossed out this column, and took the determinant of this. Okay. Next, we're going to change the sign. So it's going to be a minus. Take the second item, cross out the row, cross out the column, and take the determinant of what's left behind. So the -5, the 0, the -7, 3. So it's going to be 1 times -5, 0, -7, 3. And then last, we're going to look at this one here. So it's going to be a plus, because we just did a minus. Cross out the row, cross out the column, and what's left behind is -5, 2, -7, 2. Okay, so now let's calculate this. So we have 5 times the determinants. Let's see, so that's going to be 2 times 3, which is 6, minus 2 times 0, which is 0. Okay. Then we're going to do -1 times the determinant of this. So -5 times 3 is -15, minus -7 times 0 is 0. Last, we're going to do 1 times -5 times 2 is -10, minus -7 times 2 is -14. So that becomes a +14. So adding these all together, this gives me 5 times 6, which is 30. Let's see, minus, so -1 times -15 is +15. And then the last, let's see, 1 times 4 will give you 4. Adding these all together, that will give me 49. Okay, so that's the basic procedure for finding a 3x3 determinant. So what does this represent? Now, very often you'll just want to calculate determinants. They're useful in other formulas, even if you don't want a geometric perspective on it. But we're in 3 dimensions here. We can still understand it 3-dimensionally. And not maybe surprisingly, if in 2 dimensions we're talking about an area of a parallelogram, in 3 dimensions we're going to talk about the volume of a 3-dimensional parallelogram, which is called a parallelepiped. So let's, again, let's go back to Geogebra so we can have an understanding of what this actually represents. And I'm going to click on the 3D calculator option. And you can switch it at any point, I believe, in one of these menus here. Oh, I guess not. All right, 3D calculator option. All right, just like before, I'm going to plot each row as a point. So I have one point at 5, 1, 1, another point at -5, 2, 0, and these are points in three-dimensional space. I do want to connect this to the origin. Well, let's just put in the last point here. And my last point is going to be -7, 2, 3. Now, the first 2 points are going to make up the base, the parallelogram base for my three-dimensional object. So I'm going to do this like I did before. I'm going to have the origin as one of the points on that parallelogram. So my parallelogram is going to be made up of these points A, D, and B. But I do need a fourth point, which is going to be the sum of these first 2 points. So that will give me the other corner of that parallelogram. So 5 plus -5 is 0. 1 plus 2 is 3. And 1 plus 0 is 1. Okay, so you can kind of see it. I have 4 points here, like all along the same plane. And that represents the 4 corners of a parallelogram. All right, let's go to the tools. Remember, more tools. And even though we're now in three-dimensional space, the menus are very similar. Just click on the polygon option, and we're going to connect my 4 points to make it into a parallelogram. Remember, I don't really want a parallelogram. I want a three-dimensional parallelogram called a parallelepiped. And to make that, I need to make a prism. So in order to make a prism, you first have to make a shape, which we did. It's a parallelogram. And then I'm going to, and it gives you directions down here on what to do. We want to select our shape, and then we're going to connect it to this point over here, which they automatically named point C for us. I'm going to click on the arrow so we can kind of move around this graph if we want to. And you can see that this is basically, it looks almost like a carton or a box that got like pushed over. But we want to find the volume of the box. The volume of the box should be the determinant of that matrix we just did. We got a volume of 49, or a determinant of 49. So let's see if Geogebra agrees. Now, if I select on the volume option for measure, now that we're in 3 dimensions, there is a volume option. And I'm going to select my object, and it tells me the volume of this object is 49. If you're wondering where the C came from, if you go back to the menu, which we used to enter in stuff, there is coding here, and they decided to call my polygon some weird shapes here. They said this prism here, not polygon, sorry, the three-dimensional shape, they call it at C, and so they asked for the volume of C, and that's where that came from. All right, so one last thing I want to show is that as far as technology goes, I'll make another video with Cramer's rule, which will be an application of where we can use these determinants. If we want to use another calculator, let's call Desmos. Actually, though, I don't want the regular Desmos. I want the Desmos Matrix Calculator, which isn't in the same screen. And just use Google. It's desmos.com/matrix. If I click on here, I want to enter in, let's do the 2x2 one we did first. Let's see, the very first one we did, if you remember, the determinant, the matrix itself was 3, 5, 1, -4. Originally, we got the determinant being -17. So if I take the determinant of this matrix, you see we get 17. New matrix, it gives it a new name. The next matrix we did was also a 2x2 matrix, which is the default, and it was 1, -3, 2, 4. And again, if I just type in DET, matrix B, I get that it's 10, which is what we had before. And the very last one we did, new matrix, I want it to be a 3-row, 3-column matrix. So the first row was 5, 1, 1. Next one was -5, 2, 0. And the last one was -7, 2, 3. I find the determinant of C, we got 49, just like we calculated. All right, I'm going to pause this video, and we'll explore Cramer's rules next.